All right, we are good to go. I guess we're back on streaming. So welcome to World IA Day, everyone. So pleased and happy to be here. I'm honored to be among all of you. My name is Paul King. I'll give you a quick background on who I am. I've been in the information architecture field for about 12 or 13 years. I earned a master's degree in library and information science from the University of Illinois in the early 2000s. Then I went to work at NASA's Jet Propulsion Laboratory in Pasadena, California. After that, I went overseas and worked for research as a research associate at an institute where I helped coordinate European projects to bring semantic technologies into the marketplace. And for the past 4.5 years, I've been here at Healthwise working as a lead information architect. So as we start, I'd like you all to imagine if you had the power to continuously gather, understand, and use all the data in the world, what would you do with that power? We've seen what our government likes to do with a power like this. Prevention of terrorism, law enforcement, industrial espionage against foreign corporations. But what about us as professionals? If we had this ability, what could we do with it? Do you think we could help people work and play better? And that's what this presentation is about, to think about that question. So the reason why this question is becoming more important today is because we're seeing the emergence of what some people are calling the third era of computing. The first era started after the 1890 census, when it took us 7 years to collate and understand the data that we had collected. That was simply too long. So a man named Hollerith decided to invent something called a tabulator. And he then went on to found IBM, which then created accounting machines that were based on the tabulator. These things were quite useful for the census. And then in about 1943, the programmatic era of computing started. And that's when Colossus was released by the UK to help them in the war effort, followed 3 years later by a computer called ENIAC in 1946. ENIAC these were the first electronic general purpose computers. ENIAC had 17,500 vacuums, 5 million hand-soldered parts, and it weighed 30 tons. And every time they turned it on, the lights in Philadelphia would dim. So the programmatic era is the era we've all grown up in, and it is the kind of computer we're all most familiar with. But there is a new kind of computer that's really starting to emerge around us. And these systems, they're calling them cognitive systems, and they're based on technologies that have been around quite a while. And these new systems give us a lot of very interesting capabilities. But why are they emerging today? One of the reasons is because of the explosion of data. In fact, John Kelly has recently announced or said that this explosion of data has simply outstripped the ability of IBM to reprogram their computers. They can't reprogram these things fast enough anymore with the amount of data that's out there. They're having to invent ways that computers essentially can program themselves. And that's one of the hallmarks of these computing systems. The other thing that's happening is American Express did a little project about 7 years ago to help help detect credit card fraud. And what they did is they spun up a project with AI, artificial intelligence, and machine learning to see if they could use these technologies to detect fraud. And the project turned out to be so successful that before then, AI and machine learning were lost in academic obscurity. These were just lost fields that were not really producing much in the marketplace. When the American Express had this successful project, this created an explosion, and all of a sudden you see all kinds of money and interest in this area. So this combination of machine learning, big data, and artificial intelligence are combining to create this era. So what is a computing system, a cognitive computing system? One of the things to know about these things is that they learn and they interact naturally with us. And they extend what either you could do alone or what the machine could do alone. So it's a real symbiotic relationship that we're establishing with these new systems. The other important hallmarks about these systems is that they sense. And they're pulling in data globally from all over the place. And as you heard Sam talk about before, cleaning up data and normalizing it so that she could extract the features with R, these things don't need that. They can pull in unstructured data from all over the place with no assistance from human beings. This is a phenomenal breakthrough. Next, these things learn and they adapt from what they learn. They model knowledge, not documents. That's a big thing too. And they're iterative and stateful. Stateful is a very interesting thing, meaning these things remember the last time they interacted with us, essentially imbuing our machines with the capability to start having relationships with us. Because if that's not a relationship, an ongoing remembrance of what had happened before, I don't know what else is. So a third hallmark of these systems is that they think. And this is really the value proposition, the big value proposition that IBM's talking about. Giving them the ability to think removes us from the burden of having to program them. And they do this by generating hypotheses. We design these systems as stochastic systems, meaning they are probabilistic, meaning that we don't have to define every variable. We don't have to model the world for them. They interact with the world. They model the world. Then they test that model. And when it fails, they develop a new hypothesis. So they interact like biological systems. And fourth, and probably most important and most interesting for all of us, I think, as design professionals, is that these are not query systems. They're not information retrieval systems. They are engagement systems. So meaning that they interact with us in very natural ways. We've seen Siri and Cortana. They are conversational platforms, but those aren't the only natural ways we can interact with these things. And I want us to think about that today. They are more and more having personalities, and these personalities aren't static. They're evolving as they learn about us as users and as they learn about their environment. And they are curious. So when we can't figure out what our problem is or even what our goal is, these things will ask us questions and they'll pull data in. And so they're curious. So these are the hallmarks of a cognitive system. Now, when I was looking at this, it reminded me of something. But before we get there, I got ahead of myself. So in summary, these things are not programmed. They learn and adapt, and they interact with us in natural ways. So when I think about this, I remembered a film from 1968. Does anyone know who this is? Can you see him? Yes, hell.
I'm sorry, Dave. I'm afraid I can't do that.
So when you think, I don't know how many of you and how recent it is that you've seen 2001 and Space Odyssey, but I started thinking about it when I was thinking about this stuff, and I was struck by the fact that this is a cognitive system. In a film made in 1968 by Stanley Kubrick, based on an Arthur C. Clarke novel written probably many years before that. So they were predicting these things a long time ago. Hal interacted with Dave and the other astronauts naturally. It was not a search system. He learned and adapted as the mission unfolded, and his personality and his goals changed over time to the detriment of the other astronauts, of course. So he could see and read their lips, and when he understood what they were planning to do to unplug him, he decided he had to eliminate them. Now, that is a cognitive system, but it's also a failure of UX design, in my opinion. What would a successful cognitive system look like if the UX team did a good job? Oh.
Keep expanding. He'll be able to connect to your home.
Welcome home, Eric.
Hey, buddy. Can you order some takeout for me?
Sure thing. Chinese, as usual?
You know me so well.
And even be a great wingman.
You have a voice message from Ashley. Want to hear it?
Absolutely.
Hey, call me when you're home.
Better make that takeout for two, Jibo.
We've dreamt of it for years, and now he's finally here. And he's not just an aluminum shell, nor is he just a 3-axis motor system. He's not even just a connected device. He's one of the family.
Good night, Jibo.
Jibo, this little bot of mine.
That are here today, besides my wife. Sam, you've heard of it? Okay. So Jibo's going to hit the marketplace pretty soon. I think it's an amazing piece of technology. Personally, I want to get this out there. I always feel like I need to say this. I'm not interested in interacting with robots as human beings. That's not interesting to me. I'm not interested in like making a human being kind of thing. I'm not interested in replacing relationships. I'm not interested in replacing workers and employees. I'm not interested in teaching robots how to kill people either, like the failure of the design team that designed HAL. But what does interest me is the same thing that interests Cynthia Brazil, the founder of the company that's making Jibo. And I love the questions that she's trying to pursue here. What if technology treated us as human beings? What if it could actually help you feel closer to the ones you love, not replace the ones you love? And what if it helped us like a partner rather than being a tool? Obviously, she and her team learned a few things from HAL. So where else are we seeing cognitive systems emerge in the marketplace today? Obviously, there's Cortana, there's Siri. Facebook in November of 2015, so that's only a few months ago, released M, an AI virtual assistant for their Messenger app. Google Now, which I don't know, I mean, how many people have heard of Google Now? Google Now, like you talk to it. I didn't know it existed until a couple of days ago. So that's a new AI assistant that's coming out. IBM, they've got Watson. Why aren't they up there? Where are they? What's going on with IBM? Well, IBM just acquired a company called Cognia, which is a conversational AI platform. And I quote, "We want to create depth of personality and combine it with an understanding of the user's personalities to create a new level of interaction that's far beyond talking to smartphones." So obviously they're trying to close the gap here. And they're not far behind Facebook or Google at all. But what's most interesting is when you look below the surface. There's a lot of stuff going on below the surface here. So Google has just been in a massive acquisition spree, gathering up companies like Butyl, Wavy, Flutter, DeepMind. All of these systems together give them facial recognition, gesture recognition, a neural network, language processing, computer vision, topped off with a $400 million acquisition of DeepMind, a deep learning system, a truly deep learning system, which Watson is not. It's not really a deep learning system. What I mean by that, it still needs to be programmed. So IBM has not really achieved this cognitive system yet. They still have to program Watson in order to operate within some kind of a set of parameter, like play Go or play chess. They have to prepare it. So they have recently bought Alchemy API, which gives them essentially the ability to turn Watson into a true deep learning system. It's going to help them close that last mile, removing them from needing to program Watson. Alchemy PI provides deep learning solutions capable of advanced data analytics such as categorization of taxonomies, keyword extraction, and sentiment analysis. We see over here that Apple has recently acquired Perceptio, Vocal AI, and Emotion. Emotion, to me, being the most interesting. Emotion is a company using AI to read emotions with facial recognition, essentially imbuing your phone and our machines with emotional intelligence. So, and Nadella from Cortana has recently said that he predicts Cortana to replace the browser. Think about that as information architects. I mean, do we have a place in this new world? So that's the question I want to, I really want to explore here. Elsewhere in the field, it's just exploding with startups all over the place. All kinds of things are going on. In our field here at Healthwise, Analytic is a very interesting solution. Providing deep learning healthcare company. It's a deep learning healthcare company ushering in data-driven medicine. I don't know what that means, but we probably should look into it. The most interesting ones, though, are these frameworks. DL4J, a deep learning framework for Java. I mean, if that's not going to like accelerate this stuff, I don't know what is. H2O, deep learning architecture. How many people have SoundHound on their phone? I'm using it all the time with Radio Boise. Oh my God, what's that song? Well, they're gonna, pretty soon, they're gonna allow us to be able to talk to SoundHound. It's gonna become an assistant. In the news, very recent news, only in the last 2 months we're looking at here, we see 4 announcements of open sourcing going on from Facebook, Microsoft, Yahoo, Google. They're open sourcing deep learning modules and toolkits, an AI engine, 13.5 terabyte data set to be used to teach these systems. We see IBM announcing that Watson's going to be an ecosystem with an open API collection. What else? Well, I think then most importantly, what I see here is Merrill Lynch and Bank of America issuing a report in November stating that over the next 5 years, the AI and robotics market is predicted to triple. So there's money pouring into this stuff, and there's money that needs to be invested because of what's going on. People are looking for places to put their money. So this is a big deal. And wherever you see robotics and AI, that's cognitive computing. So again, what's the difference between a cognitive system and exactly what are the new capabilities over programmatic systems? We've already talked a little bit about this. These things are probabilistics. They don't have to be programmed. They can read in structured data from everywhere. They're representing knowledge through ontologies, through taxonomies, giving us the capability to browse knowledge, through such as Google's knowledge graph. How many of you have typed in a condition in Google recently, like breast cancer? And it gives you documents, but less and less I'm opening up documents. I'm now just looking over into the right pane so it can tell me what exactly immediately it is I'm looking for. It tells you things like, what are the symptoms of this condition? What are the age ranges that it's most prevalent in? How do I treat it? When should I call my doctor? Immediately available. That's knowledge. That's knowledge that we could not have done with programmatic. We could have done it with programmatic systems, but it would have been a lot harder. These new systems are built to represent knowledge and to give us the capability to browse knowledge. And finally, as I said before, they're more than search systems. They are engagement systems. So let's look at the use cases and applications that I quickly pulled together online. We see Skype Translate. Facebook is automatically sharing our photos with a program called DeepFace, not a program, with an application called DeepFace. It can identify the people we'd probably most likely want to share photos with. Baidu, Facebook, and Google are tagging our photo collections using AI. Spam filtering, here's the American Express. Fraud detection I told you about earlier. So the thing is, these systems, we could have created programs to do all this stuff before, prior to 2011, when the cognitive computing era promptly started at 12 on Thursday, some week. But the thing is, when viewed from the lens of cognitive computing, you got to remember that these are not programs. These are things that are learning how to do. These are systems like, think about here predictive input by Clarify. Like, think about typing in your phone. Your phone learns over time how to get better at helping you type into its keyboard. That's a cognitive computing system. So there's a lot of stuff going on. So when we think about ourselves as information architects and designers in general, I often think of this model by Donna Spencer and her book, Information Architecture. There's three things we need to know, answer questions about to do good IA, and that's we need to answer questions about people, content, and context. Regarding people, what do they do, how do they think, and what do they know? About content, what do you have and what should you have? In context, it's just about where you work. What are the constraints within which you're working? What are you capable of doing at your workplace? So it seems to me that under the paradigm of cognitive computing, we might want to reassess the user. These questions may not be deep enough. They may not be full enough. We may want to ask additional questions. We may want to stop thinking about users as asking questions, as having queries that we need to evaluate the relevance of. Users have goals. And more, especially on top of these systems, we're going to actually be able to address that users have goals, not through a proxy like returning documents, but we may actually be able to answer questions for them. And furthermore, we can actually start to accept the fact that they may not know what their goals or their problems are, because we can leverage these systems to actually tease that out of them or to help clarify that for them. And furthermore, they may not, their understanding of their goals may change over time. Also, we are stymied by big data. Like, let's help them make sense of that. How can we, in the jobs that we do, developing the programs that we are developing for our users, can we use big data? Can we make it more understandable for them? And lastly, context is foreground now. Users are the partners, right? We can gather a lot more information with the big data that's out there about our users and our clients. Can we use this? You know, we can get tweets, public records, blogs, purchasing patterns, friend connections, travel patterns, where did they grow up, languages we speak, pets we have, education that we have, neighborhoods we live in. And if we know lots of these things, we can also draw a lot of conclusions about new facts about people. You know, so think about, if you're a developer, if you're an IA, if you're an interaction designer, and you have beneath you, you know, this cognitive computing capability, that means you can start to pull a lot more stuff together to serve your users. So it seems like it might be time soon to reevaluate these questions. At least let's look at the people sphere here. What do they do? What do they think? How do they think? And what do they know? It's probably time to think about a lot of other questions that we can start to address. And so I'd like to take a moment and ask all of you if anything occurs to any of you, like any new questions we might ask ourselves as developers, as architects, as designers, if we were working within a cognitive computing paradigm. What are the questions we think we might like to start asking our users? And I hate to call you out, and if you don't want me to, I won't, but your program seems like it might be a nice place. Like, maybe we could all as a group think about what you're doing with your startup company. And I'm not even sure if this is going to go anywhere, but it might be fun to think about, if you had a cognitive computing capabilities, would you or could you think about different features that you might include within your program for your users? Does anything come to your mind? Wait 1 second.
So software development, you have to do this thing called MVP, right? So we're starting with registration, kind of snoozer, but it is like, that's like the first hook, and then it's going to build from there. So the long-term vision is to actually make it interact with wearables and actually display really interactive graphs and charts, and give you information back to help you do training, help coaches train kids, help create this sort of community space within athletes. And so within there, that learning piece, each person is going to have a different experience. So the idea would be that, you know, when you think about designing, you think sort of that single track, like you go here to here to here to here, but ultimately it's going to end up needing to be much more flexible, and it's going to need to learn from each person to be its best form. So I imagine that, yeah, totally interactive and learning, because then you'd know what your behavior was like, you know, if you're a runner and you haven't been running, and why, what might be prohibiting you from running? Are you ill? You know, are you traveling? Like, what are the things? Can it remind you? Can it talk to you? A simple thing that I love is, like, in Slack, you can customize like the notifications that like come up at the beginning when you open it up. It's like funny things that greet you as you're launching the product. So the current vision right now is to sort of pre-populate some of that content into our app. So when you first open it up, the home screen prompts you with different questions in sort of its status feed, if you will. But an intelligent engine could really help drive that question to be more engaging, to actually help that individual talk back to their friends and collaborate with their teammates in a much more interesting way.
I love it. And I think that your use of the word collaborate is key, because the system then becomes a method of collaboration, right? It's not a program, it's a collaborative platform, right? So I love that. I love, did we have another?
Oh, I was just going to say, I'm not sure if this applies, but I could imagine too, if combining all these sources of information, like if you had an athlete's performance, over time, you might then also start being able to deduce make like meal suggestions to them. Like you need more carbs this day. And then furthermore, what grocery store has sales on this amount of carb that you needed, or it's get a weather report. It's going to be 50 degrees. Make a suggestion of the clothes that you should wear for your optimal performance, or hydration needs.
In the back we have.
So Paul, I was really interested to see the companies you had listed, but was surprised not to see Amazon, because when I think about all the data that Amazon is capturing on each of us, including me, and my buying behaviors, and that's now reflected in my Facebook feeds, and I actually won an Amazon Echo at a training event and have had it in my house, and it's awesome. And because it's like, it's not quite as cute as that little GB guy, but it's become an interactive for everybody in the family. So I think it's really interesting that this is happening. It's happening in kind of quiet ways. But I had somebody ask me, I was talking about the Echo, and somebody came over and they said, oh, I've been trying to convince my wife to let me get one of those, but she's afraid that Big Brother's watching and I don't want them to have all of our data. I said, they have it anyway. Why don't you want, why wouldn't you want to benefit from it? But I just think Amazon, and it's everywhere. We're already sharing all that data.
Yeah. Yeah, absolutely. It is everywhere. And that's, I think this is a really timely time for us to think about this as designers. One other thing, Wendy, that you mentioned, okay, I have to move on. So, so here are some questions, that I had come up with on my own that I think are relevant within this paradigm. We could start asking them, like, for example, are they bored, scared, or frustrated? Have they tried this before? These are stateful systems. It knows if you've tried to solve a problem before. So I want to move on. Finally, there's another aspect to being an information architect specifically that I think we might want to think about in this new paradigm. And it might be time to reassess the idea of information. And it might be time to deconstruct our profession a little bit. This profession's not been around for very long. 12 years, am I off? 15 years maybe? I don't know, time flies for me, maybe 10. But, it's always been linguistically oriented. It's always been rooted in linguistics. So it's about labels, navigation, taxonomies, ontologies, more recently. But, information can be more than that. And it might be time to really dive into other fields like semiotics, which is about the study of meaning making through signing or through signs, indication and designation and likeness, metaphor, symbolism, communication. According to this 1948 paper by Shannon, communication is a message conveyed with a signal. So maybe within this new paradigm, as we are interacting with these systems in much more natural ways, not just conversationally, but in other ways that are natural, it might be time to deconstruct the idea of information to a signal, right? One thing I like to think about an application in which you want a heads-up display on a bicycle because it's important that your eyes are always on the road, and you don't even want to have them read anything, right? So imagine a navigation system. Maybe you put 2 plugs into your handlebars, 2 plugs in your pedals, and 1 in the seat so that they vibrate with different kinds of vibrations. Left tells you to turn left, right tells you to turn right. The seat tells you there's a car following too closely behind you. Both handlebars vibrating at the same time are telling you better stop very quickly. I don't know. These are signals. Is this not information that's been architected for an appropriate environment? Is it not a natural way of interacting with the system? That's a cognitive system. So it's time, I think, possibly very soon, if not already, to start thinking about information architecture, possibly in a much broader and a much deeper way. And where I think also as a result of this, we're going to see a lot more overlap with interaction design. So where does interaction design stop and information, in this sense, architecture start? I don't know. I only have questions today. So finally, this is a framework. I probably only got a minute or no minutes left. then all I was going to say about this is a framework for the cognitive computing platform coming out of the book, Cognitive Computing and Big Data Analytics. And all I really want to say about this is I think that as design professionals, it's important to have a coherent vision, a cohesive idea of, I think all of us have components of these systems within our organizations. I know we have a knowledge engineering team that does this stuff over here. We have an analytics business intelligence system over here. We have a UX team that does that over here. But this coherent vision of how everything can be brought together and work together to provide a whole, because essentially in the end, it's really serving, isn't it really in the end serving users? And so us as designers, I think it's incumbent and important for us to really understand how all of this can and should and probably will, sooner or later, with or without us, come together within a framework very much like this to produce these systems. And that's it. Thank you, everyone. I'm sorry I went over time.
Questions for Paul?
So what are the dangers you see in going forward with this, and how would you deal with them? Or
well, we've seen what Hal did. The dangers. Well, drones, I don't know if they're cognitive systems, but they will probably be more and more like cognitive systems as they're pulling intelligence from the cloud. I think that with all technologies, there's like a dark side and a light side. Drones can be used to bomb anonymous citizens in Yemen, and they can also be used to plant entire forests on mountainsides within hours. There's a team working at a university that's designed drones that can pick up seed balls, fly over a mountainside, and shoot these things at the appropriate depth within the soil to instantly plant an entire forest. So the danger, killing people is always the danger. Is that what you're kind of curious about? Or?
About the privacy issues as well.
Yeah, absolutely. Would anyone else like to comment on that? Because I don't feel like I have much to say about that.
I read an article yesterday by this guy, Robert Epstein, talking about, it's called The New Mind Control, and he has a forthcoming book about this too, and just essentially how much power companies like Google and Facebook have to influence our opinions without us even knowing. And he's done some interesting studies that show that even when people know that their opinion is being influenced, in those rare cases, that they still are influenced, and that doesn't give them any immunity to the influence. So, for example, just showing how simple manipulation of the same 10 results within the first page of a Google search result about a presidential candidate to put the things that say favorable things about a candidate higher in the results can actually influence up to like 25% of people to vote for a different candidate. So I think, yeah, with great power comes great responsibility with this stuff, and we really owe it to ourselves as a community to use this data in ways that help humanity, and rather than help only the bottom line of the corporation that we work for or something like that.
Next, Marlene.
Oh, mostly a statement. I think, well, having lots of experience working with developers who are awesome. I love people's brains that can code and that really understand structural computing. But there is a need for people that, like you're saying, that understand the sort of higher level order. So how it all works together, designers, thinkers, information architects, I don't see it ever going away. It's just going to change from my perspective.
Yeah, and to me, I think that's one of the biggest things that I hope you're taking away, is that there's a coherent vision out there that the world is kind of formulating, and we either need to understand it and know how to use it for ourselves and our professions within our organizations to help pull these pieces together. Because we're going to be able to do our jobs much better if we can put these pieces together in a coherent system.
This is kind of a comment or a question or something, but I see a lot of these AI devices are auditory. You interact with them auditorily. And I just think it's interesting because when I watch younger people interact with devices, they're moving even further away from making phone calls. Like people are doing more texting. For instance, there's a new guy at work, and I just showed him how to use the phone. He's been there 8 months. So he hasn't used the phone before. So it's just kind of a comment, like it's going to auditory, but in other ways I see people moving away from that. So I'm wondering how that's going to work out.
I am too. Yep. Okay, thank you,
Thank
everyone.
you, Paul. All right. So we need to raffle some stuff. And Boston continues to be dark, so I think we'll go on to the attraction of atomic design. So Maria and I will do some raffling. Annette will do some setting up. And what do you think, Maria, about more polar bear book? So we have three big, they are.